Hey everyone, this is your key for your very first study guide in chemistry this year for our very first test. So for number one, it just says to define chemistry, and you guys took notes, hopefully, so I don't think I need to do that for you. I think you can handle it. And then for number two, write 5 of the 6 major areas of chemistry and briefly describe them in your own words. On my study guide, I wrote down the 6 major areas of chemistry: analytical, physical, biochemistry, nuclear, organic, and inorganic. And I can't describe them in your words, but if I were just going to do a brief overview, I would say that analytical is concerned with the composition of substances. Biochemistry has to do with processes in the body. Organic has to do with carbon-based substances. Inorganic is anything not containing carbon. And then nuclear is having to do with nuclear reactions. And physical is very math heavy, so it has to do a lot with rates. Number 3 says, what is the difference between pure and applied chemistry? The main difference between them is that pure chemistry has to do with gathering knowledge just for the sake of having that knowledge, while applied chemistry is working more towards a goal or a purpose. Applied chemists are trying to develop something for a practical use. And then number 4, listing several items that have been designed by chemists. There were several on your notes. I just listed 3, but there could be many, many more. So I listed Velcro, nylon, and penicillin. Number 5 was describe at least 2 industries that chemistry is essential in and why it is essential. So on my study guide, I listed 3 industries, and the reasons that chemistry is essential is pretty obvious in each one, but each one of these was in your notes, so if you can't come up with something that you just come up with in your head, which you probably could, then it is also in your notes. Number 6 was to draw the metric system staircase and write down how each prefix relates to the base unit. So I just kind of did it off to the side here. There was enough space, and this is only some short answer over here. So I just wrote the abbreviations, which is fine, still useful. So kilo, hecto, deca, your base units, which would be the meter, the liter, the gram, things like that. Then deci, centi, and milli. And then how they relate to the base unit. Well, there are 10 base units in one of these, 100 base units in one of those, and 1,000 base units in one of those. And then down here, you're going to the smaller end of the spectrum. So deci is 1/10 of a base unit. This is 1/100th of a base unit, and this is 1/1000th of a base unit. So there would be 1,000 of these in one base unit. So you could say there's 1,000 millimeters in a meter. So now we're writing the base units for each of the following. So the first one is temperature. The base unit for that is Kelvin. And for length, the base unit is going to be the meter. So base units are the things that do not have prefixes in front of them. They're the ending of the word, the base of the word. Letter C was mass, so the gram is a base unit. And letter D was volume, so the liter is the base unit. Number 8 was using these metric system steps, the staircase, to actually convert between metric units. So the first one was to take 23.6 centimeters and change it to meters. So centimeters is here, and my base unit of meters has no prefix. You can tell because it's only one letter. If it was a prefix in front of it, it would have something here. So I'm taking centimeters here and converting to meters, which is a base unit. So I'm going to go 1, 2 to the left. So my decimal went 1 to the left to give me 0.236. And now I'm taking centimeters to millimeters. So I'm going from this step to the right one. So my decimal went to the right one step to give me 236. decimal move from here to there. And then I'm going to decimeters, so from centimeters here over to deci, lowercase, so one step to the left. So my decimal goes one step to the left to give me 2.36. Okay, second row, doing 456 millimeters, and I want to take that to centimeters. So I can imagine that my decimal is right here. So I'm going from millimeters here over to centimeters, so one step to the left. So my decimal goes one step to the left. It's going to land me right there to give me 45.6. Now I'm going to meters, which is the base unit, no prefix again. So I'm going from milli to 1, 2, 3 to the left. So I'm going to take and go 1, 2, 3 to the left, which means my final answer is going to be 0.456. And then I've got to take it all the way to a hectometer. So I'm going to start with my decimal here at the end, and I've got to go from milli all the way up to hecto. So 1, 2, 3, 4, 5 to the left. So 1, 2, 3, 4, 5 to the left. So that means I'm going to have a decimal here in the front, 2 zeros in my little loops, and then 4, 5, 6. So that's how it's done. So now I'm just going to show you what I got for the rest, and don't be surprised if you find a mistake. It's happened before. In fact, I hope you do, because that means you understand. So look closely at the rest of these. Feel free to pause your video and make sure and take a good look at these. Here are the last couple of boxes that are on the other page. For number 9, it says to describe the procedure you would use to find the density of a regularly shaped object. Example would be a rectangle. So we've done this before, so I just wanted you to think back to a good procedure to tell somebody to use. So here's the one I came up with, and yours may not necessarily match, but could be just as right. So first I would tell them to measure the length, width, and height of the rectangle and record that in metric. So centimeters, meters, whatever it takes. Step 2, multiply length times width times height to determine the volume and record that. Number 3 would be to mass the object and record that mass. And then number 4, calculate density by taking mass divided by volume, where your mass is in grams. And in our case, when we take length times width times height, we're taking centimeters times centimeters times centimeters, which gives us centimeters cubed. And that's for a regular object that has not been in a graduated cylinder. Okay, I'm seeing a lot of labels being mixed up. Centimeters cubed and milliliters are equivalent, but that does not mean they are the same. If you are measuring in centimeters and determining volume, volume is going to be in centimeters cubed. If you're measuring with a graduated cylinder, you are measuring in milliliters, so your density should be measured in milliliters. It should be labeled as milliliters. So now you're going to describe the procedure you would use to find the density of an irregularly shaped object, so something that you can't do length times width times height. So here's the procedure that I came up with. First, take the mass of the object and record it in grams. So you want to do that before you ever get the object wet, because the next thing you're going to do is fill a graduated cylinder to an amount that will submerge the object and record that volume in milliliters, because you're doing a graduated cylinder. Then step 3, drop the object in the cylinder carefully so it doesn't splash, and record the new volume in the cylinder and take the final volume minus the initial volume to determine the volume of the object itself. A lot of people are forgetting that. The volume of the object is not how much the graduated cylinder goes up to when it's dropped in. You have to subtract. Number 5, calculate the density by taking mass divided by volume. In this case, your mass is in grams and your volume is in milliliters because you used a graduated cylinder. So the label on your density would be grams per milliliter. Then on to number 11, a piece of tin has a mass of 16.52 and a volume of 2.26. What is the density? Just take it step by step. Density is mass over volume. So put those things in place. Mass is in grams, so I know the 16.52 goes on top. And then I just divide out the 2, and I got this big long number right here. So I wrote the whole thing out because you have to determine your significant digits. This one has 4, this one has 3. So your answer has to match the one that has the least. So since this one has 3, your answer should also have 3. So I rounded this 0 up to a 1 because there's a 9 behind it. So 7.31 grams per centimeter cubed, because that's what it told me right up here. For number 12, we're determining if this sample of wood could possibly be oak. So once again, you're taking mass over volume. So I placed my 2 numbers there, 25 grams over 35 centimeters cubed, because that's what I was given. So then I come out with that division and I get a big long number. So once again, I check my digits. There's 2 there and 2 there, so my answer should have 2. So 0.71 and grams per centimeter cubed, which matches the density of oak. So yes, it is. So now we're determining the mass of a piece of pine. Okay, so that's all in the question, mass of a piece of pine. So we have our density here and we have our volume. So mass over volume there. So we just sub in what we have. We had the density and we had the volume. We're solving for mass. So then that means my 0.5 has to move over to the other side with multiplication because it's being divided here. So it has to be multiplied over there. So we multiply these two together to get M, which gives us 400. In our data, that has one significant digit, and so does this. These are not to the right of any decimal. So my final answer has one significant digit right there. So 400 grams. Make sure to include your unit. For number 14, we're looking for the volume. So it gives us the mass and the density. So we're going to plug those into this equation. We had the density, which is 9.0. We have the mass, which was 32.5, and we're looking for the volume. So in order to solve that, it becomes this in my head. The V is multiplied by the 9, leaving the 325 over here by itself. So then to get V by itself, I had to take 325 divided by 9.0, which gave me this big long number. So again, significant digits. This one has 2, so my answer should have 2. So I rounded this to 36, and it's centimeters cubed, unit of volume, because my density has centimeters cubed here. And last on this page, number 15, it tells you that a graduated cylinder was filled with water to a level of 40, and a piece of copper was lowered into the cylinder, and it raised up to 63.4. So I illustrated this. The graduated cylinder was here. When we dropped the copper in, it raised up to 63.4. So that means I have to take 63.4 minus 40 to get the actual volume of the copper. And then to get the mass of the copper, I take the density, which is given here in the question, sub in the volume I just got, solve for mass. So again, they're multiplied, and I come up with this number. And then for significant digits, that one has 3, that one has 2. If I round up to 210, only these two are significant because it's not to the right of the decimal. So 210 grams. For 16 through 19, we're just converting between Celsius and Kelvin. So you're going to either add 273 or subtract 273. Kelvin has the big numbers, so I knew I was supposed to add on these two. These are my answers. For these I subtracted, and those are my answers. For scientific notation, I put this little note on the side. You'll be able to see it fully in a minute, but it's the thing that I wrote on the board. If the number is greater than 1, the exponent is positive. If the number is less than 1, the exponent is negative. So I can decide right away, this number is way less than 1, so my exponent's going to be negative when I decide what it is. So all I have to do now is move my decimal to where there's one real number in front of it. So I move it 1, 2, 3, 4, 5, 6 times to get my 6 there. And I moved it 6 times, so it's going to be times 10 to the negative 6th. And that's how I did all of these. First, I decide whether my exponent is going to be positive or negative based on the original number. That one had to be positive, way more than 1, positive, negative, less than 1, and negative again. Then I just count to where I have one number in front of my decimal. So these were what I came up with. Now converting it back, that previous statement still helps. This is a positive exponent, so I know this number was greater than 1. So that means my decimal has to go to the right. So I'm going to move it to the right 5 times. 1, 2, 3, 4, 5. So I'm just going to have 5 zeros behind it. Same method for all of these. You can see where I moved my decimal. And based on whether it was positive or negative, I knew whether to make it greater than 1 or less than 1. So now we're determining significant figures. And so the first one, all non-zero numbers are significant, so it has to be 5. This one has 2 zeros. So first question to ask yourself is, are they sandwiched? The answer is yes. Sandwiched between this number and this number, so all 4 of those numbers are significant. For this one, I have several zeros, so I ask myself, are they sandwiched? No. So I move on. Are they to the right of the decimal? No, because there is no decimal. So that means there is one significant digit right there. Go ahead and do the second row with you. My only zero is right here. First question, is it sandwiched? Yes, so it is significant. So all 6 of those. Now I've got a couple of zeros here. It's a few in the front and 1 behind. So are any of them sandwiched? No. Are any of them to the right of the decimal? Yes. 1, 2, 3 of them are. So if they are to the right of the decimal, then you ask yourself, are they final? Only that one is final. So there are 3 significant digits. Over here, same thing. Are there any of them sandwiched? Yes, that one is sandwiched between the 5 and the 6, so it is significant. Are there any to the right of the decimal? Yes, right there. Is it final? Yes, so all 6 of those are significant. So here's all of mine for that question. So for 23, using significant figures rules to take measurements, I'm going to do one of each tool, and then I'm going to let you kind of take it from there. So the first one is a ruler. So the object you're supposed to measure didn't come in, so I just drew a line. You can draw your own line. But either way, this is how you do it. The 5 is marked, so that is for certain. And then I have little tenths markings in between here. There are 10 little markings. So my tenths place is for sure. And I counted over, there's 5, 6, 7 tenths. Okay? Then I have to look really closely to try to estimate the last digit because the hundredths place isn't marked. So that's the one I have to estimate. And if I were estimating this one, I would make it a 5. So that would be correct for that. So I went ahead and drew another little line here for my second ruler, and so you can kind of maybe tell how I got my numbers here. The 2 was for certain, it's marked. The 8 was for certain. There are 8 little tick marks that I went up to get to that. And then I estimated the last one. I admit it, these are a little hard to see, but you just kind of have to do your best. And as long as you know what you're supposed to do, it's fine. It's not necessarily getting the right answer on this study guide. Okay, so for here, the 30 line is marked right there, so I knew that for sure. The tenths are marked, I knew that for sure. So now I just have to guess one more. So that is my estimated digit for this. Which I just changed it because I had an extra 0 in there for some reason. It's 32 for sure. 30 is marked, so 1 and then 2 gives me the 32. Then I have to estimate the tenths place, just like on the graduated cylinders you used in our penny lab. So this was my estimated digit, and that's where I stop. So I'm leaving the rest of those graduated cylinders for you to estimate according to the rules. I can take a look at them if you'd like me to. And then I'm just going to finish up with these last few calculations, calculating density and using significant figures. So it's mass over volume. I put it into my equation there. This is the number I came up with. My final answer should have 3 because this one has 3. So I rounded to 3.89 because of this 5. So there's my final answer. For B, determining density again, put my mass over my volume, came up with this number. My final answer should have 3 digits, not 5, because 3 is the least. So then I rounded to 1.76 because of this 9, so there's my final answer. Again, calculating density, so mass over volume here gave me this number. This number has 3 significant digits. That 0 is to the right and final. So my final answer has 3 digits in grams per milliliter because milliliters is right there. And the last one says for you to go back and check your significant figures on 11 through 15. I already did that with you, so that should be good to go. Hopefully things went well on this. If you have any questions, let me know, and good luck on your test.